Okay, so just a very quick look at this week's AS homework. We're basing it on Surds and Indices, but a little bit of earlier algebra stuff in there as well. This one, that's question 1, solve the equation. Well, we've multiplied the brackets, so 6 lots of 4 is 24. 6 times the minus 2, so minus 12x is minus 9x. We have to balance the equation. Let's take the 12x to the other side. 24 is 3x, and then divide both sides by 3, giving us 8 as the answer for that one. Of course, you can check it by summing it back into the equation. The question 2 was using these laws of indices. Now expressing these in simple terms, 8 to the minus 3 is a fraction, so that's 1 over 8 cubed, and negative power means it's the reciprocal, 1 over that fraction, 1 over that value, and 8 cubed is 512, 8 8 64 times 8 is 512. Evaluate 27 to the power of 2/3. The fractional power here, the third bit, means the cube root. So 27 to the 2/3 is the cube root of 27 squared. If we cube root 27, we get 3. And if we square that result, we have 9 as our answer. And this one here, we need to get it in terms of the same base number, the base being 6 here. 36 to the 12, we'll write that as being 6 squared to the 12 times 6 to the minus 18. We would multiply the powers. In this case, this would be on your list of laws of indices. So 6 to the 24 times 6 to the minus 18. And again, when we're multiplying, we would add the powers. So 24 plus minus 18 leaves us with 6 to the power of 6. On to the next one. And we've got some work on surds, simplifying surds. We've got root 20 minus 24 over root 6. Well, if we work at this one bit at a time, the 24 over root 6, we need to rationalise the denominator. So we'll multiply top and bottom by root 6. The 20, well, if we think about 20, that is 4 times 5. 4 is the biggest square number that goes into 20. So it's root 4, root 5. Here we've got 24 root 6 over 6. Root 4, of course, is 2. And 24 divided by 6 leaves us with 4 root 6 there. And then we've got it in the form a root 5 plus b root 6. Doesn't matter that b is a negative number, minus 4 in this case. That's our answer. On to question 4, where we want to rationalise the denominator. We need to make sure we're multiplying this by 1, but we choose 1 to be in the form of 3 minus root 5 over 3 minus root 5. If we carefully multiply out what we've got 7 3's, we've got 21, minus 7 root 5, plus 3 root 5, and root 5 times minus root 5 gives us minus 5 at the end. On the bottom line we've got 3 3's and 9. Minus 3 root 5 plus 3 root 5, the difference of two squares, they cancel out. Minus root 5 times root 5 is minus 5. Giving us 16 and minus 4 root 5 on the top. 4 on the bottom. 4 is a common factor of top and bottom, so we end up with 4 minus root 5. And again, we've got it in the form n4 plus n root 5 minus 1 root 5. And the final question, solve the equation 2 to the t minus 1 is 8 to the 2 minus 7t. We need to get it in terms of the same base number again, so we're going to start by saying 2 to the t minus 1 is 2 cubed to the 2 minus 7t. Again, using our laws of indices, we would multiply the powers. Be careful to multiply the whole thing. So it's 2 times 3 is 6. And 3 times the minus 7t, so minus 21t. Now that we've got these both in terms of the same base number, the powers must be the same. So we can forget about the 2's. t minus 1 is 6 minus 21t. Rearrange this, add 21t to both sides, add the 1 to both sides, and our final answer, t is 7/22, and that's maths.